Welcome to CS Foundations, looking at 2D arrays in Python's Part 1. And what we're looking at right here is John Horton Conway's Game of Life. He first kind of developed that in 1970, so this is a bit of an honor to that, and it's been 50 years since. And it's a small little simulation. It's a zero-player game that just runs on itself once you give it the initial condition. I could go in here and click on an individual cell and change things. So I'll click right on there, and it's like, what? Boom, and that thing explodes into that, which seems simple enough. Add another one, and now it's going to go on and on and on. So, well, more on that. You'll see that in our example. So a lot of games, a lot of computer science is based around working with things that come in a grid. Sometimes you'll hear there's a 2D array, matrix, a lot of different terminologies. I'll touch on that at the end. But in Python, it's actually going to be done with something called a list of lists. So that's the implementation term, but more often than not, you're still just going to call them a 2D array. That's if you go and Google and search for 2D array, these are the kind of answers you're going to find. Now, in the sample code we have that goes with this, for example, there's one that's based on the loops, and you're going to see a lot of nested loops, a lot of for all the rows, for all the columns. And you're going to see this down at the very beginning when we're going to actually make the data structure. What we're going to do is going to make a grid that's going to be an empty list right there. And then we're going to make an empty row. And into the row, we're going to append a whole bunch of falses. So now we've got one full row. And then we're going to append that row into the grid. And now we've got a full set of rows. And each one has its own columns in it. It's a bit obtuse, honestly. There are simpler ways, and we'll see those in the future. But when we're iterating through them, it's pretty simple. We're going to see the for row and for column and then turn around and say something. So here, this is an example of how we could clear the whole screen out. Now, as we dive into what the data structure looks at, let's look at our global map of concepts we'll learn in computer science. And so the 2D array is definitely a form of a value. It's got a simple primitive Boolean inside of each cell, but the 2D array itself is a data structure. We'll look at that more. When we're looking at this data structure, it's important to sort of see that, yes, we will be using loops a lot with working with the data structure. And then the data structure it's non-trivial. And so if we want humans to read it, we should spend some time thinking about how we're going to communicate the internal state so that it could be observed by people outside. And namely, it is people I'm thinking about for this game here. Although, obviously, if you have 2D structures, you might be wanting to, like how we might communicate to other computers. And if you think of like a picture as a 2D data structure, it's a grid. And an example of that would be how would you get an image into the computer? Suppose we want to take a picture and use that as a seed. But the main thing for today is going to be, as far as that one, we'll touch on the communications from the drawing point of view, our execution, and our values. And we'll touch on this stuff. Oh, undo. Well, we'll just go on there. Oh, there we go. Okay. Yeah, and we'll touch on some of that in the future. Now, since it is a data structure, of the data types, we're going to focus on Boolean and lists here. So we got in some of both. Now, the list of lists. So in this example, we'd start off by making row A and row B. And so row A is false, false, true, false, false. Row B is false, true, false, true, false. And if we've executed that code, we now have two symbols, row A and row B, and they're referring to an internal data structure. And we've given a visualization to it, and in our program, we just use it. You were using pygamezero to do paint recs of different colors, so I'm using that in the screenshots. Now, to make a grid or to make a two-dimensional data structure based upon that list, all I do is use that same list construction and say grid is equal to a list consisting of row A and row B. And then voila, we've made a two-dimensional data structure. Now, looking at that, so this is the way you might frequently draw it if you're just doodling it on paper and just say, okay, I've got a grid and it's got two rows, and inside it, it's got, there's 5 columns. Now, if I want to index an individual part, so I'm writing an algorithm that's going to look at into each cell. Well, all I have to do is take the grid and then index the grid to get the first list, the 0, 1, indexing at 1. And then with that list, I'm going to index it again And in this case here, we're going to end up indexing out that cell right there. So the way the computer treats it, just to restate this, is it just evaluates it left to right. So we get the symbol that refers to the top list. We index that list. That returns the inner list. And then we index that list. And then the answer is set. So you could have lists of lists of lists if you wanted a 3D array, for example. Okay, now let's just peek back underneath the hood just a quick second. Important is to know that when you're dealing with lists, they're always handled by reference. They're an object. So the grid is actually its own list, and you should definitely think of it the way it's drawn here. So it has a list, and the containers in it are simply references to the other list. So row A and row B are still there, and they're still pointing to the same thing. Pointer is the term you use in C++. Reference is the term you more often use in Python or Java. But fundamentally, know that row A is referring to a block of memory that the grid is referring to. And that means if I came here and I executed the code in Python and said row A sub 4 equals true, I'd actually be changing this cell. And that's the exact same cell that the grid would see. So this is an important definition, alias. So anytime you have in your program, you have more than one way to refer to a variable, then you'd say that in this case, we'd say row 4 sub A is an alias to grid 0 sub 4. Or I could just say that row A is an alias to the first row in the grid. So that can be a real big help because that allows you to take a complex data structure and pass subsections down to functions that then work on that data structure in place. And when it's all done, all the work is there. It can also be the source of bugs if you don't know where your aliases are. So it's important to understand. We can't go into all the nuances right here, but that's it. So looking at the next bit in here, I figured I'd just touch base on this idea of lists versus arrays versus other terms like matrices. So where did these terms come from and which one kind of wins out in different space? And this is definitely one where there's no simple answer. 2D array or two-dimensional array is something that just didn't exist before the mid-1900s because what it was dealing with when we had computers and had just blocks of memory. Memory was implemented in a whole bunch of different ways, but sometimes you'd think of like magnetic core or other stuff like that. But it was just a big flat sort of sea of values. And so they started coming up with a concept for how to deal with chunks of memory that they'd use for math operations. And so they'd have an array of that memory. And the default would be sort of, it's like a linear array, like a single dimension array. And then when you're doing math operations, a little more complex, you'd think about it abstractly as a two-dimensional array of memory. Now, the memory didn't change. It's just the way they described it. Now, but that's when computers. But mathematicians have been working with, I said the word right there, matrices, for some time. And that's kind of the interesting piece of here is, yes, the idea of a matrix is kind of took root in the mid-1600s, kind of in the era of Isaac Newton, René Descartes, and Blaise Pascal. Descartes is where we get the Cartesian graphing system, so the two-dimensional graphing surface. So the idea of 2 dimensions or 3 dimensions, and the way of referring to them came back in way back there. So the idea of 2D, but what you're seeing actually here, just an example, is so it was a mathematical concept, but there wasn't a whole lot you could do other than, whoops, that's not what I wanted to do right there. There we go, okay. Until that computer era, again, 1950s, when all of a sudden we started doing operations on matrices. And there's a lot of ways of referring to them. It's interesting that once we began to have a lot more memory and the computing power, we didn't have to do something that was as hard-coded as it was originally done in languages like Fortran and C, which were very fixed in their size. You couldn't append stuff. You had to think of everything ahead of time, so the array term worked out very well. Lists was more dynamic, and then they really kicked in once we had computers and we had languages like Python, Java, several other ones. And then it came down to what term they called it. Was it a list? Is it an array? And it does get kind of confusing because if you look down here, like all the different terms, lists of lists, arrays of arrays, and two-dimensional arrays. But in the end, this is kind of what's winning out in terms of just how people talk about the data structure abstractly, independent of how an individual language implements it. And so in our case here, when we think of Conway's game of life, you'd more or less just describe it as a two-dimensional array of cells, maybe a matrix of cells. So that's it. So that's 2D arrays as a list of lists in Python and part 1. Blessings to you all. Bye.